Hello and welcome everyone to the second lecture of our course titled An Advanced Non-Orthogonal Multiple Access Security Technique for Future Wireless Communication Networks. In this lecture, we will be discussing the proposed system model. In the proposed system model, we have considered two users and use U1 and use U2. There are two users at the transmission side and there are two users at the receiver side. So the transmission data or the transmitted packet of user 1 is denoted as x1. We consider, by the way, we consider a OFDM system model, and we are building our NOMA transmission on top of the OFDM system model. So first of all, the x1 and x2 data packets of the user 1 user 2 passes through the modulator, then the serial to parallel converter. Then we have these specifically designed precoder matrices, m1a, m2a, m1b, and m2b. In this system model, we use antenna diversity, where we use multiple antennas, antenna 1 and antenna 2. Also, we have introduced simultaneous transmission from the two antennas. That means user 1 data is first superimposed with the precoder M1A, and the user 2 data is superimposed with the M2A. Then similarly, user 1 data is also superimposed with M1B, and user 2 data is also superimposed with M2B precoder, and these transmitted packets or the data symbols are the information. This transmission is performed simultaneously from the two antennas. That means we have these specifically designed precoder matrices superimposed with the user 1 and user 2, which results in automatic interference cancellation. We will be explaining how it does the automatic interference cancellation due to this in the next mathematical equations slides. So due to this automatic interference cancellation, we don't need to use the successive interference cancellation, which reduces a lot of complexity in this model. Also, this simultaneous transmission from the two antennas, where we are using four precoders for two users. That means user 1 data is first precoded superimposed with the precoder M1A. It is also superimposed with the precoder M1B, and this information is transmitted simultaneously from antenna 1 and antenna 2. Similarly, for user 2, it is superimposed with precoder M2A, and it is also superimposed with precoder M2B, and it is transmitted from antenna 1 and antenna 2 simultaneously to the user 1 and user 2 respectively. So this model eliminates the use of successive interference cancellation. It introduces antenna diversity, and it reduces the complexity due to which due to which the processing of the data, the processing from transmission, we have, by the way, we have shifted all the complexity at the base station, and the channel, and reduce and minimize the complexity at the receiver. These procoders are channel dependent, and this is where physical layer security comes into play. So there is very limited, there is no complexity at the receiver side, due to which it can easily decode its own uh, data, and there is no use for the like power sharing in the there is no need for power sharing as in the conventional NOMA scheme. User 1 and user 2 will not be sharing any power. They will be getting their own respective in, data from the transmitted user, and that's even there is no chance for the eavesdropper to decode the information because of the specifically designed precoders and the dual transmission. It is very difficult for the eavesdropper to decode these two specifically designed precoders for each user, and the misrupt or interrupt this uh, dual transmission, this simultaneous transmission from the two antennas. So we have also considered a passive eavesdropper in our system model. So the novelty behind this proposed system model is that you don't need any successive interference cancellation. There is simultaneous transmission from two active antennas, where we have introduced antenna diversity. It provides perfect secrecy because of the precoders, simultaneous transmission from two antennas, automatic interference cancellation, security against both internal and external eavesdropping, less complexity, and it is suitable for IoT devices, 5G and beyond. The comparison of the proposed system model and the conventional NOMA. In conventional NOMA, we have far user, near user, there is power sharing, then the successive interference cancellation. So this is what I explained in the previous lecture, and here we have the proposed system model, which has simultaneous transmission from two antennas, and it is combined and received at the respective users without any interference. So that's it for this lecture. I will be talking about the proposed algorithm in lecture 3. So I hope to see you guys in the next lecture.